In 2017, we had Oumuamua pass through the solar system. In 2019, Comet 2I Borisov did the same. What these two objects have in common is that they originated from outside the solar system and were the only two objects known to do so. On July 1st, 2025 though, astronomers detected a third interstellar object racing towards the Sun. This came to be known as Comet 3I Atlas, and it's going to reach perihelion on the 29th of October, 2025. Every day, astronomers are learning more and more about this comet. The Asteroid Terrestrial Impact Last Alert System, or ATLAS, is an automated astronomical survey that constantly scans the skies for asteroids that potentially pose a threat to Earth. It is a system of 5 telescopes located in various places around the globe. Of interest for this topic is the observatory located in Rio Hurtado, Chile, part of the Atacama Desert. On the 1st of July, 2025, astronomers there announced that they had detected an object entering the solar system at a speed of about 58 kilometers per second. This speed is very important, especially given that this comet was discovered way out near the orbit of Jupiter. An object that orbits the Sun that far out has no reason to be traveling at such a high speed. Furthermore, astronomers were able to look at images of the object from before its discovery and determined that this object showed a hyperbolic orbit. What this means is that it will pass by the Sun and leave the solar system. These two key facts are what led to the conclusion that this object was interstellar in origin. The name was given 3I Atlas. 3I signifies that this is the third interstellar object ever discovered, and Atlas, of course, signifying its discovery by the Atlas survey. Further observations the day after its discovery showed it was active with cometary activity. Thus, just like Oumuamua and Borisov, 3I Atlas is a comet. Comet 3I is notable for its extremely hyperbolic orbit caused by its excessive speed. With an inbound velocity of 58 kilometers per second, it is by far the fastest interstellar comet ever discovered. For comparison, at their discoveries, Oumuamua was moving at 26 kilometers per second, and Comet 2I Borisov was moving at 32 kilometers per second. 3I's speed has been increasing ever since its discovery, and will reach a maximum of 68 kilometers per second at perihelion. As a result of this speed, 3I's trajectory also has the highest eccentricity of either Oumuamua or Borisov. It poses no threat to Earth, and will pass us at a comfortable distance of 1.8 AU on 19th of December 2025. During this time, Comet 3I should be observable with an 8-inch telescope under dark skies. This is really the only chance to observe this comet, as during perihelion, the comet will appear too close to the Sun to safely observe. 3I's characteristics have been studied in depth and fine-tuned as it has been approaching the Sun. The James Webb Space Telescope has observed the comet with its near-infrared cameras, and in the corresponding study authored by Martin Cordiner and others, they present that they found that 3I consists of an abundance of CO2 gas, along with some amounts of water ice, water vapor, carbon monoxide, and carbonyl sulfide. Of main interest to astronomers is the comet's abundance in CO2 with an 8-to-1 ratio, possibly the highest ever observed in a comet. The reason for this abundance is unclear, but may be related to the way Comet 3I was formed in its host star system. It is likely that Comet 3I is the single oldest comet we have ever seen, and astronomers have good reason to believe this. Tracing Comet 3I's trajectory back, it appears to originate from the Sagittarius region, which is towards the center of the Milky Way. The particular region that 3I originates from is called the thick disk, and it's mostly composed of older stars. A large population of them are thought to be over 10 billion years old. Thus, a study by Matthew Hopkins and others estimated with 68% confidence that Comet 3I is anywhere between 7.6 and 14 billion years old. For comparison, our solar system is estimated to be just 4.6 billion years old, meaning that Comet 3I must be older than any comet we've seen that has originated from our solar system. Now, it's difficult for astronomers to pinpoint the precise system where 3I originated, but a study by some researchers in September 2025 suggested that 3I has possibly passed within 3.3 light years of 25 known stars in the past 10 million years. Comet 3I is expected to reach perihelion on the 29th of October 2025, where it'll pass about 1.39 AU from the Sun, traveling about 68 kilometers per second. Because 3I is going to be on the opposite side of the Sun as the Earth, it cannot come close to it, and therefore poses no threat to us. 3I actually passed by Mars on the 3rd of October 2025, at only 0.19 AU from it. And on the 3rd of November 2025, it will pass 0.65 AU from Venus. On the 19th of December, it will then make its closest approach to Earth, at a comfortable distance of 1.8 AU. And finally, on its way out of the solar system, 3I will pass 0.36 AU from Jupiter. While the possibility of launching a space probe to 3I is remote, spacecraft that are in the path of 3I's several planetary encounters have the chance to make their own observations of the comet. The European Space Agency, or ESA, commanded their Mars Express and ExoMars TGO orbiters to take highly detailed photos of 3I to be able to better characterize its activity. Their other attempt will be with JUICE. JUICE stands for Jupiter Icy Moons Explorer. It is a spacecraft which was launched in April 2023, and it is on its way to Jupiter to study the icy moons Ganymede, Callisto, and Europa, all of which are thought to have subterranean oceans which may be habitable for life. It is currently in transit, but Comet 3I will pass it at a distance of 0.43 AU, and ESA will wake up the spacecraft to observe the comet using cameras and spectrometers. The particle sensors, which will be used to analyze the content of the cryovolcano geysers on the icy moons, will also be used to try and pick up some material from the comet. Unlike the vast majority of other comets that are popular in the science press, 3I is not a bright comet, and if used from Earth will not be impressive. It will not be visible to the naked eye at any point in its encounter with the Sun, nor with binoculars, but rather with a modestly sized backyard telescope. Think 8 inches and up, and away from light pollution. Alternatively, long exposure images may be possible with smaller telescopes. The best time for its observation will be in the month of November, when it will be visible in the morning, just before sunrise in the constellation Virgo. It is not expected to get brighter than magnitude 11, except for an unexpected outburst.